Okay, guys, so this video is going to be solving equations involving radicals. And this time we're going to take a look at some equations that require us to, first of all, isolate the radical. Then we need to undo the radical by applying square root. And then we solve for x, and finally we do have to check our answer, and we have to do this as it says in capital letters for every single example. So let's start with looking at this first example. So I'm just writing on my screen, you're going to be typing in Desmos, right? So let's go ahead and see if we can find the root. So for this example, I can see that the radical is right here, square root of 2x, and it is not isolated. So you got the plus 1 on the same side with the radical, so that's not good. So you need to subtract 1 from both sides. So what is that going to do? Well, that's going to turn this into square root of 2x on the left hand side, and then here it's going to cancel. On the other side you get 3 subtract 1, which is 2. Okay, so now that we isolated the radical, we need to get rid of it. So you need to remember, to get rid of the radical, you need to square both sides. Okay, and when you square both sides, you need to put the expression that was under the radical in parentheses. So it's very important. I want to put parentheses around here, and then I'm going to square, and then I'm going to square over here. So that whole thing was under the radical. So when the square is applied, the radical just disappears and we wind up with just having 2x on the left side. On the other side, so this is a very typical mistake a lot of students do, is that they don't, they think that 2 is going to cancel, the square will cancel with the radical, and it's also going to cancel on the other side. But that is not true. So on the other side, you've got 2 squared, and that squared is going to stay squared. So you're going to get 4 over here. Okay, so the last step is, remember, the default operation is multiplication. So we're going to divide both sides by 2. And so in this cell, you're going to type x equals 2. Now, in the next cell, you actually have to enter either capital Y or capital N, depending on if the solution you found, which is x equal 2, is that really a solution or not? Because sometimes what happens is it's not. So you need to check it. It's called the extraneous solution. Okay, so what I'm going to do is just erase everything that I was doing before on the very first cell, because I want to go back to the original equation and I want to replace x over there, so with this number. So that number, so that goes into here for x. Okay, so what will happen? So I'll get square root of 2. And remember, again, default operation is multiplication. 2 times 2 plus 1, and I need to see if that's equal to 3. So square root of 4 is 2 plus 1, that is indeed 3, so check. So in the cell, you're just going to type capital Y. So it checks whether you type capital Y or lowercase y. I think you better type capital Y, that is going to be correct. All right, so we checked it, we know. Let's move on to the next example. So let's take a look at example 4. So in this example, the first step is already done for you because the radical is already isolated. So you can see that the radical is on one side and everything else is on the other side. So that step we can skip. Now the next step is to get rid of the radical by squaring. So just remember, to kill the radical, we square. Okay, to kill the radical, we square. So we're going to square this side and also square the other side. So what's it going to do? It's just going to cancel that radical. So you're going to wind up with 7x minus 62 on the left-hand side. On the right-hand side, that will be 1 squared, which in this case is just 1. So because 1 squared is 1, so that's it. So to solve this equation, okay, so for the next step, you actually already have to write x equals something. So I'm not checking this next step. I'm kind of skipping ahead. But let's do this on the side. So if 7x minus 62 equal 1, that means that if we add 62 to both sides, we will wind up with 7x equals 63. Okay, and then the last step is to divide both sides by 7 to cancel it over here. And so 63 divided by 7 is 9. So x equals 9 is the solution to the original equation, but we still don't know 100% if that's true because maybe it's extraneous. So let's go ahead and erase everything that I had here, and let's plug in the x we got, which is this 9, in for x over here. So that's very important. Plug it back in and see if it works. So remember that the operation that is between 7 and x is multiplication. So we want to know if 7 times 9, which is 63, is minus 62. What is that? Well, that's square root of 1, and that is indeed 1. So this is a solution, so you will be typing y in the box under there. Okay. For the last example of this video, we're looking at example number 4. I'm sorry, example number 5. So here also the radical is isolated, but the way we usually define the radicals is that the answer to the radical should be positive. So there is something funky about this equation in that the right-hand side is negative, and that is probably going to be a problem, but let's check that out. Okay, so first the radical is already isolated, so we're going to square both sides. Now, when you square both sides, you got to be very careful to put the expression that you're squaring in parentheses. So the negative 5, when you square, it's not the same thing. So notice the difference when I have something like this and something like this. In here, this is negative 5 multiplied by itself. So when you multiply it by itself, you get positive 25. Whereas over here, the negative is outside. So this is negative of 5 times 5, which is negative 25. So there is a difference. This one results in a positive 25. This one results in a negative. So if the negative is inside parentheses, it'll disappear. If the negative is outside, then it is not disappear. It's going to stay. So here, when you square in both sides, you gotta put that stuff in parentheses. So what's going to happen on the left-hand side? The square is going to cancel with the square root, and we will wind up with x plus 4 equal to negative 5 squared is not negative 25. That is positive 25. So don't make that mistake. Okay, so next we're going to subtract 4 from both sides. We're going to wind up with x equals 21. So now our next step is to check to see if this is really a solution or this is one of those extraneous solutions. So let's see what happens. So let's go back to the original equation. Let's take 21 and let's put it in for x and see what happens. So we've got square root of 21 plus 4. That is square root of 25. And it's asking you, well, that's 5. But is that equal to negative 5? So the answer is obviously no, it's not. And as I was telling you, the answer from the square root is not by agreement ever negative. We always agree that the answer is positive. So in this case, 5 is not equal negative 5. So that is actually not a solution to this equation.